Assalamu alaikum, dear students. In this lecture, we will be learning what's determinant. As we have completed matrices in the previous lectures, now we're going to learn the determinants. First of all, let's know what the determinant is. What's its definition? Since you know there are a number of matrices, for example, we have a row matrix, we have column matrix, we have null matrix, we have CQ matrix, CQ symmetric matrix, we have symmetric matrix and skew symmetric matrices. We have triangular matrices. We have a lot number of matrices. But the determinant, the concept of determinant is associated only with those of the square matrices. You know, square matrix is a matrix having equal number of rows and columns. So what is determinant? Determinant, the definition of the determinant you can see from here. It's actually a function that associates with every square matrix a scalar quantity. Okay. For example, we have a function from set of all square matrices to the set of numbers, real or complex. So for every square matrix, there is associated a number. But the question is how to calculate this number. What are the methods we'll be learning in the coming lectures. The determinant of the matrix is denoted by A within these two lines, two bars. So its notation is like this, I will be highlighting here, or DETA, or this determinant notation. For a matrix A, this is called a determinant. This is called a determinant. Note that it's not read as modulus here. That's the concept in the real and complex number systems. So one point that's important that I would like to highlight once again, that is only square matrices have determinants. Non-square matrices do not possess determinants. So the first point is that if we have a square matrix of order 1, what is its determinant? Its determinant is equal to the element itself, the value of the element itself. How to calculate the determinant of order 2? So in order to calculate the determinant of a matrix of order 2, we will be following this procedure, multiplying this A11 with A12 and multiplying this A21 with A12, but subtracting this non-diagonal entries from the diagonal entries. So this quantity, the subtraction of these numbers, that is actually the determinant associated with 2 cross 2 matrix. Similarly, we can find the determinant of a 3 cross 3 matrix. For a 3 cross 3 matrix, we can evaluate it along any row or along any column. For example, we want to evaluate the determinant along the row 1 of the matrix. So how can we calculate this? This can be calculated like this. We will expand this determinant along row 1. For example, A11, we will be writing A11 and multiplying it with the determinant of this submatrix A22, A23, A32, and A33. You can see it here. This quantity I would like to, this quantity. Then similarly adding the number this and its corresponding entries, that is this one, this one, this one, and this quantity. And next one, the quantity associated with A13. So the summation of all the three steps that gives the determinant of the given matrix. Now, here are some remarks. You may please go along with these remarks. Here is the question, how to evaluate this determinant. This is a determinant. We are supposed to evaluate this. Here, I would like to tell you one important point, that is, we should expand or evaluate a determinant along that row or along that column that has maximum number of zeros, because that's very easy. For example, in the column number 3, we have maximum number of zeros. So we will evaluate this along column 3. So it is 4 into its submatrix, the submatrix, this 4 into submatrix this, that's this one, this one. So -1, 3, 4, 1, and 0 into this submatrix and 0 into this sub. You will evaluate this and you will find the addition of all these three quantities that's equal to the determinant of this matrix. Similarly, you can solve example number 4 in order to understand the concept, and example 5 as well. I hope you have got the concept. But if you have any queries or questions, you can ask in the comment section of the YouTube link. Thank you for joining the class. Have a nice day.